Alrighty, folks. We're going to start with number 12 here. Number 12 is they're asking you to find the equivalent resistance in micro ohms. And so remember, this is one like we did yesterday, where your Y is all the different circuit diagrams that you're going to do along the way, and your how is solving for the different values as you reduce this step by step. So I'm just going to grab my diagram here. So it's not a full circuit problem in that we don't need the plot and all of that stuff, but we need to do all the diagrams. Notice there was a tutorial that went along with this one. So some people find those very helpful, some people find them very frustrating, but just to make you aware of those so that in case you find them helpful, they can be used there. All right, let me shrink this down some. So I'm going to be cheap and use that as my first diagram, and not but on like the test or something, you would redraw this. Seems really not better. All right, so I need my R1 value. My R1 value is 3.22 microohms. 3.22 microohms. And I need my R2, which for me is 11.6 microohms. Right. And so I'm looking at this now, and I can actually do two steps at the same time here. So remember, I'm looking for resistors that are strictly in series or in parallel. And I have two that are in series over here on the right-hand side, on the left-hand side, excuse me. Those two are in series because there's only one path through them, so the current has to be constant through them. And then over here on the bottom right corner of the circuit, I have two resistors that are in parallel with each other because they both have both ends connected to each other, so the same voltage across them. So I can actually reduce this by twice in one step. Are you guys okay with that, or do you want me to do them each separately? Just, yeah, okay. Good, because I'd rather. So I am combining these two into a single resistor because they're in series, and I'm combining these two into a single resistor because they're in parallel. I'm going to do the series part first. So I know that our total for a series is R1 plus R2 plus ... R to the n. And so here I only have two, so RTS equals the 3.22. Can't even read my own writing. Yep. So 3.22 microohms plus 3.50 microohms. Kind of do that one in my head. 6.72 microohms. So that's what those two are going to combine to be. Draw a little arrow just to help out. And then I'm going to do these. So 1 over R total parallel equals 1 over R1 plus 1 over R2 plus plus 1 over Rn. And so I have 1 over RTP equals 1 over 0.75 micro ohms plus 1 over 11.6 microohms. And this, I can't do this one in my head, so I'm going to pull out my calculator and do 0.75 minus 1 plus 11.6, 1 over 11.6. And then I don't want 1 over, I want my RTP, which will end up being 0.70445 microohm. Now, one thing you can do to check to make sure that you've done your math correctly is in a series circuit, the resistance should get higher when you combine, and so 6 is higher than 3 or 3, so I'm pretty confident there. And in a parallel circuit, because there's more branches, the resistance should actually go down and be lower than either of the resistors. So 0.70 is lower than 0.75 or 11.6. So I'm pretty confident there that I did the correct ones. I'm just going to double check my numbers. Yep, my numbers are good. So I'm pretty confident that I did my math correctly. I'm going to redraw my circuit. Read this time, so I have a resistor here. Up. Resistor there. Over to here. I have a resistor. Another resistor. So this is my circuit now. This is my 8 micro ohms. This is my 1.5 micro ohms. This is my 0.70445 micro ohms. And this is my 6.72 micro ohms. So I've reduced my circuit from 6 resistors down to 4, right? And I'm ready to do my next one. Any of those resistors now in series or parallel? Which one? These two are in series with each other, and these two are actually in parallel with each other. I think I'll just deal with the series ones right now. All right, and then I'll deal with the parallel ones, and you'll see why. I'll deal with them after I redo my circuit. So for the series ones, I have our total series equals 1.5 micro ohms plus 0.70445 micro ohms. So this is now 2.2045 microohms. Well, I'm in the middle of the problem, so I'm really trying to keep all of them. I'm keeping them in my calculator. At the end, of course, 3 sig figs, right? For during work time. And the reason that I didn't bother with the parallel ones is that, in my opinion, it wasn't going to save me any work, because after combining the 2 series ones, I'm going to end up with these 3 in parallel to each other. And I can actually, rather than doing math twice, I can just do it once. And so this is my 2.20. So actually, by not combining them previously, I think it's going to say it's going to let me do one less math equation. So now these are all in parallel. So I have 1 over RT parallel equals 1 over 6.72 micro ohms plus 1 over 8 micro ohms plus 1 over my 2.20445 micro ohms. going to get RTP. Pull up my calculator. So, clear it off. 1 over 6.72 plus 1 over 8 plus 1 over 2.2044. We're not doing any trig functions, so it doesn't matter. And that would be my 1 over RTP. If I need to make that stand on its head, get RTP, and I get 1.37 micro ohms. And technically, I should draw my last circuit and label it 1.37 micro ohms. That should be right. Huh? Yes. Did you get a number less than 1 for 1 over RTP or for RTP? Because remember, like from my calculator, this intermediate that I didn't write down was 1 over RTP for me equaled 0.72743741129. And then I did 1 over that to be able to get my actual value for RTP. But you might get a number less than 1. I should check that mine. Again, since you're standing right there, could you type that 1.37 in there for me? Oops, you gotta click in the box. Yay!
Sorry, Billy says you can too.
No, I looked before I touched, just so I wouldn't mess. Yeah. Thank you for doing that. All right, so number 7 we're gonna do. And number 7 would be a full-blown circuit diagram, plot, currents, everything. And you should make sure you refer to the rubric here about the 5 parts that should be in your Y for problems involving circuits with diagrams. All right? So that will be key to not losing points meaninglessly. I'm going to grab this circuit diagram just to reference, but I'm going to draw my own. So, all right. So this is. Notice that I'm using one of the new redesigned circuit sheets. So you want to use one of those that is double-sided there. All right. And let me do my diagrammy thingy here. And I'm going to put in battery. Excuse how messy this will be. It's hard to be as neat on the board as I would be if I was drawing this on paper. So. Make sure you get the positive and negative sides of your battery copied in there correctly. That makes a huge difference. And this is 6 volts. And this is 9 volts. And my resistors are, let's see, R1, 29, and R2 is 17. 29, 17, 29, 17, 29 ohms, and 17 ohms. Alright, so that's what I would expect for a circuit diagram. I've used the correct symbols. I've drawn the correct circuit, which, yeah, that's one of the steps. And now I'm going to indicate the currents in that circuit. How many different currents do I have? 3. There's 3. And how many junctions do I have? 2 junctions. 2 junctions Remember, current always runs junction to junction. So I'm going to do, and I'll color code mine. I'm going to do, I want to go from positive to negative. So I'm going to do I1, and it's going to go around that upper branch like that. And then down here I'm going to do I2, and it's going to go around that lower branch like that. And then my I3 is going to be across the center here. I'm not really sure which direction it's going to go, but I'm going to look at my junction and say, okay, in that right-hand junction, do I have at least, does one of my currents go in and one of my currents come out? And the answer is yes. So I can either have my I3 going into that junction, so in other words, going left to right, or I can have it going right to left. Which way do you guys think? I'm going to pick left to right. Thank you, London. That would be I3 in there. So, I'm also going to arbitrarily pick that here at between the 9-volt battery and the 29 ohm resistor, when I get around to plotting, I'm going to call that 0 volts, just for convention. So now I need to draw my circuit on my grid here. That will look like this. And now, what is the criteria on our rubric for the plot? What's the wording I use? Usable. So I'm not grading you on artistic ability. Thank goodness I'm not being graded on artistic ability. I'm grading you on, is it usable? So, can it be understood? Was it obvious that it was usable for you in the making? So there's my base circuit. I know that right here between the battery and that 29 is at 0. That means on the other side of the 9 it's going to be up at 9 volts. So I'm going to draw a bunch of lines here that are hopefully close to the same length, because that length is going to be my 9 volts. And I think those are kind of close to the same length. And then I know that over, when it goes from the negative side to the positive side of the 6-volt battery, it's going to go up 6 volts. So that means I have to go 9 and then 6 more. So I'm going to have a lot of really tall ones over here. So now, actually, I have all my ups. So let's see, I said this was at 0, goes up 9, across, all of these are staying the same. And then it goes up 6 more. Oh, I drew my current I drew my I3 going the wrong way. Should have picked the other direction. It's okay. Well, because see how my slope goes up? My slope would have to go down. So I'm going to reverse my I3. Well, let's live and learn, right?
Oh, I had it.
So I'm picking the other direction for my I3. And good. That's what it would look like. And this would be labeled as, I read, this is 9 here. This slope here is going to be 29 I1. This slope here is going to be 6. And my other slope, which is right here, is my 17 I2. I3, excuse me, I3. not the prettiest plot I've ever done, but usable. Yeah, it is confusing in the middle.
So, on the other side, oh, it's okay, so basically.
And this is why probably, because that one looks confusing to me, even, probably when I go to make my loops, I'm going to look more at my drawing on the left than my drawing on the right. But the drawing on the right is also showing, hey, I know I grasp how to do these plots, which is one of our measurables. So, you guys told me 2 junctions. So, 2 junctions always produce how many junction equations? 2, but how many unique equations? 1. Careful, it's like there are 20 cows. How many of them are white? You told me 25. So be careful of that. So one unique equation. And so that's going to be, my one unique equation will be that I2, I'm doing the right-hand junction, I2 equals I3 plus I1. No. No. That's the beauty of addition. Order doesn't matter. I'm being funny, I don't even. How many loops do you guys see?
I can go and have
Practice. We have a bit of 4. 3?
3.
Four. Matt, are you agreeing with your table mate? You're going to say 3? All right. I don't want to pick on people who are working on other problems that are not working. I'll skip over some people. What do you guys think? 3? There are 3 loops. There, if you think of it as like a figure 8, there's one around the top circle, one around the bottom circle, and then there's one around the whole outside. So I'm going to do the big outside circle first. Actually, you know what? I'm going to draw these right underneath it and then move them down. So the big outside circle, I'm going to go counterclockwise. So I'm going to have 9 plus 6 minus 29 I1 equals 0. I'm going to go around just the top. I'd have 9. Ooh, I'm going the wrong way. I'm going up the slope across the 17. So it's plus 17 I3. And down the 29 minus 29 I1. And then around the bottom one, I'll say bottom left corner. 6 minus 17 I3 equals 0. Well, these are actually pretty straightforward equations. I'm just going to move them to where they make more sense. Yeah. Because I could solve that top one for I1, right? I could solve that bottom one for I3. Do you want me to still use the solver or just do them manually? Manually, okay. Okay. So, in this one, I would have 15 equals 29 I1. So I1 equals. And in this one, I would have 6, this one, equals 17 I3. So I3 equals. Grab my calculator. 15 divided by 29. I get 0.5172 amps. And 6 divided by 17. I get 0.5172 0.35294 amps. And then I'm going to do that center one. Oops. And then, so now I need to do the green one for I2. So I2 equals I3, 0.35294 amps plus 0.5172 amps. So I2 equals my answer plus that one. And I get I2 is 0.8702 amps. And now it might be a good idea to look and see what did they actually ask me to find. They want to know the current through resistor 1, the current through resistor 2. So resistor 2 we said left to right. Resistor 1 we said right to left. And then I can type in those values, see if we get it. So my I1 is their I1, right? 0.5172. And, okay, give me 1 second, can I look at it? And then my I3 is their I2, so 0.353. See if I got this right. Oh, that's right, I had to reverse that one, didn't I?